Let us see the problem. Change the order of integration in integral over 0 to a, integral over 0 to b by a, root of a squared minus x squared dy dx, and then evaluate it. So today's concept is change the order of integration. Right. So first of all, write the solution. Consider the entire integral is, let I is equal to integral over 0 to a, integral over 0 to b by a, root of a squared minus x squared dy dx. First of all, we have to check whether the written integral is in the correct form or not. What is meant by a correct form? Suppose, see here, the inner integration with respect to y at the time, the limits in terms of x. Already here, as it is, the range of y is nothing but 0 to b by a, root of a squared minus x squared, that is in the form of x. And the outer limit is a constant 1. So easily we can say this is nothing but in the correct form. Now we are going to draw the bounded region now. Before that, we have to write the ranges first. Here, y varies from y equal to 0 to y is equal to b by a, root of a squared minus x squared, and x varies from x equal to 0 to x equal to a. That are the limits, that are the ranges given in the problem. Take y is equal to b by a, root of a squared minus x squared. Consider the range of y is equal to b by a, root of a squared minus x squared. Right? Take y is equal to b by a, root of a squared minus x squared. So we want to remove the square root now. So taking square on both the sides, therefore y squared is equal to b squared by a squared into a squared minus x squared. Right? Therefore, y squared into a squared, cross multiplying, that is equal to b squared a squared minus b squared x squared. Right? Therefore, x squared b squared plus y squared a squared equal to b squared a squared. So throughout it divided by b squared a squared. At the time what we get? Therefore, x squared by a squared plus y squared by b squared equal to 1. Therefore, the given region, the respective region is nothing but an ellipse. This is an equation of an ellipse. Let us see this diagram. Here x varies from x equal to 0 to x equal to a. So the corresponding point is nothing but a comma 0. Here we draw the line. We named that it is x equal to a. That is nothing but the major axis of an ellipse. And then y varies from y equal to 0 to y is equal to b by a, root of a squared minus x squared. So y varies from 0 to. So here I mentioned already y equal to 0. So 0 to b by a, root of a squared minus x squared. That is nothing but an ellipse, x squared by a squared plus y squared by b squared equal to 1. That's why that is nothing but this curve. So we mentioned that it as an ellipse, x squared by a squared plus y squared by b squared equal to 1. This is the minor axis. So the corresponding point I mentioned that it is 0 comma b. Here the line is nothing but y is equal to b. Suppose the point of intersection, here the point of intersection we are having, that is nothing but a comma b. And in our problem they mention x squared into dy dx. So for the corresponding representation I mentioned here for an vertical strip. That is for our convenient only. I mentioned that it as a vertical strip. Now what is our problem? Change the order of integration. Order of integration. So now we want to change this vertical strip to horizontal strip, because we need to change the order of integration. At that time, how can we write our I? I is equal to double integral over x squared. Already we are having dy dx. Now we mentioned that it as dx dy. So now we want to write the limit of x. What about the range of x? That is in terms of y. We need the limit of x in terms of y, and y limit is nothing but the constant 1. Now I is equal to integral over 0 to b, integral over 0 to a by b root of b squared minus y squared x squared dx dy. Already we changed the order. Therefore I is equal to integral over 0 to b, inner integration with respect to x. The integration of x squared is nothing but x cube by 3. The range of x is nothing but 0 to a by b root of b squared minus y squared into dy. So I want to replace the upper limit and lower limit now. That is equivalent to, here 1 by 3 is a constant. I took it outside. 1 by 3 integral over 0 to b. So a by b, so a cube by b cube into, here power 3, x power 3, and here we are having root of b squared minus y squared, that is nothing but b squared minus y squared the whole power 1 by 2. So we have to replace the value of x cube by this. That's why it can be written as b squared minus y squared. Already power, here power 3 and here for 1 by 2. So the multiplication is nothing but 3 by 2. So a cube by b cube, b squared minus y squared the whole power 3 by 2 into dy. Again I took this constant outside. So already 1 by 3 is there. So a cube by 3b cube integral over 0 to b squared minus y squared the whole power 3 by 2 into dy. So now we need one substitution for this integration, evaluation of this integration. We need some substitution. That's why I put y is equal to b sin theta. So dy by d theta, differentiation with respect to theta. dy by d theta is equal to b as a constant. Differentiation of sin theta is nothing but cos theta. Therefore, dy is equal to cross multiplying b cos theta d theta. Now we want to know the limit of theta now. So what is the range of y now? 0 to here. So when y is equal to 0 to b, limit of y is nothing but 0. dy is equal to b cos theta d theta. Now we want to write the range of theta. So how can we write? Here y varies from 0 to b. So I mentioned here y equal to 0. What is the value of y? Y equal to b sin theta. Right? So y equal to 0. So b sin theta. I need the value of theta. Automatically the theta value is nothing but 0. And what is the upper limit of y? Y is equal to b. Therefore, b is equal to b sin theta, right? Because y is nothing but b sin theta. So, b get cancelled. Therefore, sin theta is equal to 1. We need the value of theta, right? So, theta is equal to sin inverse of 1. At that time, what is the value of theta? Theta is equal to pi by 2. How can we write? Sin inverse of 1, that is nothing but sin inverse of sin pi by 2. The value of theta, sin theta is nothing but when it becomes 1 sine pi by 2. The value of sine pi by 2 is nothing but 1. So inverse and sine get cancelled. Automatically theta value is nothing but pi by 2. So now the range of theta is nothing but theta varies from theta equal to 0 to theta is equal to pi by 2. Now I is equal to, already we are having a cube by 3b cube outside. So a cube by 3b cube, range of y varies from 0 to pi by 2. Already we did it. And then the integrand is b squared minus b squared sine squared theta. Because here we are having y squared. Y is nothing but b sine theta. That's why we wrote like b squared sine squared theta the whole power 3 by 2. Already we are having here. And dy. So the value of dy is nothing but b cos theta d theta. Already we derived. That is equal to a cube by 3b cube integral over 0 to pi by 2. I want to take one b squared outside. So b squared, already the power is nothing but 3 by 2. So b squared the whole power 3 by 2. Remaining here 1 we are having. So 1 minus sine squared theta the whole power 3 by 2. Already we are having here b cos theta d theta. That's why a cube by 3b cube, right? Integral over 0 to pi by 2. Here 1, 2, 2 get cancelled. So simply we are having b cube 1 minus sine squared theta, that is nothing but cos squared theta, the whole power 3 by 2. Here we are having b cos theta d theta, right? So that is nothing but a cube by 3b cube integral over 0 to pi by 2. B cube into b power 4. Here 1 square and 2 get cancelled. So that is nothing but cos cube theta and cos theta d theta, right? So that is nothing but a cube by 3b cube integral over 0 to pi by 2 b power 4 cos power 4 theta d theta. I want to take this constant outside. So what we get? Therefore, I is equal to a cube by 3b cube, right? And 1b power 4 here, that is nothing but constant. That's why I want to take it outside. So into b power 4 and integral over 0 to pi by 2 cos power 4 theta d theta. Okay. Here the range is nothing but 0 to pi by 2. At the time for integration, you are going to use recurrence formula. What's that formula? We know that integral over 0 to pi by 2 cos power n theta d theta. That is nothing but, how can we write? Numerator is nothing but n minus 1, n minus 3. It's going on divided by n into n minus 2, n minus 4. Likewise, we are having the formula. Suppose this n is nothing but even, finally we can write into pi by 2. So here the value of n is nothing but 4, that is even. So how can we write this? A cube by 3b cube. Again 1b power 4 is here. So how can we write? N minus 1. So n is nothing but 4. So 4 minus 1 b. After that 4 minus 3, that is nothing but 1 divided by n value is nothing but 4 and 4 minus 2, that is nothing but 2. And the n is even, that's why we want to multiply with 1 pi by 2. So what we get? B power 4 b cube. So simply we are having a cube b, right? Here 1 3 and 3 get cancelled, and numerator we are having 1 pi. Am I right? A cube b, okay fine, divided by 4 2s are 8, 8 2s are 16. Okay, right. So this is the answer for the integral I. That's the thing. So that is I is equal to pi a cube b by 16. That is the required answer. Thank you.